Our objective today is that the student will be able to find the least common multiple of two or more numbers. Our vocabulary that we will use today: first, we need to know what the word multiple means. It is the product of a number and two or more numbers. Then we have common multiples. A common multiple is a number that is a multiple of each of two or more numbers. And then finally, the least common multiple, or LCM, is the least multiple that is common to two or more numbers. Now, to begin, we usually just list multiples to find the least common multiple, and you guys probably did something like this, at some point last year. So I would start with my multiples of 10 and my multiples of 12. All right, and we make a list of multiples. And remember, multiples are the product of a number times another number. So 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30, and so on. 40, 50, 60, 70, 80, 90, 100. Right? I'll stop there, see if that's enough. We have 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. Times 5 is 60. 6 times 12 is 72. 7 times 12 is 84. 8 times 12 is 96. 9 times 12 is 108. And we'll stop there. Right? Let's underline common multiples first. Let's see. I don't see. Here's my first common multiple, 60. All right, and if I would have continued these, right, if I'll continue, right, we have 110, 120, 108. That's 9 times 1, so that's be 120. Right, so if I underline common multiples here, I see 60 is common to both, 120 common to both sets of numbers, which means every 60 we would have another common multiple. But the least common multiple would be the lowest number that is common to a set of numbers, and that would be 60. LCM is going to be 60. All right, let's try 7 and 10. All right, if I list my multiples for 7, we have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. I'll see if that's enough. Multiples of 10. We have 10, 20, 30, 40, 50, 60, 70, 80, 90. Do we have anything in common yet? It looks like 70. Right, 70 is common to both sets of numbers, so that would be the least common multiple. Right, it's going to be 70. Okay, we'll try a few more. Right, why don't you guys try some on your own, and then take a look back at the video and see how they're done. Right, we'll try 3 and 8. Right, 3 and 8. I have 3, 6, 9, 12, 15, 18, 21, 24, 27. For 8, we have 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 32, 40, 48. 8 times 7, 56. Do we have anything in common yet? Let's see. Do I see 8? I don't see 8. Do I see 16? But I do see 24. Right, if I start with the larger number and look for the same factor in the smaller set of factors, or multiples, right, and I would find 24 would be the least common multiple there. Okay, let's try number 2. Let me label that number 1. Let's go to number 2. Number 2, do that in green. We have 9 and 12. So I have 9 and I have 12. For 9, we have 9, 18, 27, 36, 45, 54, 63, 72, 81. And for 12, we have 12 times 1 is 12, 24, 36, 48, 60, 72. Least common multiple, start with the larger number. Right, I don't see a 12, I don't see a 24, but I do see 36. So that's going to be my least common multiple. Right. Problem number 3, or our third example. Let's try 6 and 10. Do that in black. Problem number 3. We have 6, and I have 10. For 6, we have 6 times 1 is 6, 12, 18, 24, 30, 36. 6 times 7 is 42. 6 times 8, 48. Let's see, for 10, we have 10, 20, 30, 40, 50, 60. Least common multiple. All right, I don't see 10, I don't see 20, but I do see 30. So my least common multiple is going to be 30. Here, I didn't write it, but my least common multiple is 36. And this example, our first one, least common multiple was 24. All right, so it's very easy to list your multiples of two numbers and look for the least common multiple. Have to be careful with our times tables though. Now, there's another method that we can use to find the least common multiple, and that's using our prime factorizations. All right, we can use the prime factorization of a number to find the least common multiple, and this is very useful if we're talking about larger numbers, or if I'm talking about 3 or more numbers where we're looking for the least common multiple, because if we have to list a large set of multiples, it's very likely sometimes that we forget a multiple. So this is a good strategy to use if we're using finding the least common multiple of larger numbers. Okay, so let's see how it's done. If I'm starting with example 4, I have 14 and I have 18. Right, first I start with my factor tree for 14. For 14, we have 2 times 7 is 14. They're both prime. So the prime factorization is going to be 2 times 7. Right, if I do a factor tree for 18, I know that 2 times 9 is 18. 2 is prime. 9 is not prime. Right, 9 can be factored as 3 times 3, where 3 is prime. So the prime factorization for 9 is 2 times 3 times 3. Right, let's fix that. Now, to find the least common multiple, we identify each factor the greatest number of times it appears. Well, 2 appears once. Let's undo that. Right, 2 appears once to the first power. 3, I have 2 powers of 3, and I have 1 power of 7. I identify each factor the greatest number of times it appears. Your least common multiple is going to be the product of those factors. So I take 2 times 3 times 3 times 7. Right? I underline each factor the greatest number of times it appears. I multiply. 2 times 3 is 6. 6 times 3 is 18. 18 times 7, that's going to be 70, and 56, which would be 126, would be the least common multiple of 14 and 18. And that would be a tough one. If we had to list the multiples of 14, list the multiples of 18, and go all the way out to 126, that would be tough to do. But by using the factor tree and to find the prime factorization for each of those numbers, we can find the least common multiple. Okay, let's try the next one. We have 28 and 36. I start with my factor tree for 28. 28 is 4 times 7. 7 is prime, 4 is not. 4 is 2 times 2. They're both prime. For 36, I factor 36. It's going to be 4 times 9. Neither is prime. 4 is 2 times 2. 9 is 3 times 3. They're both prime. I write the prime factorization for 28. That's going to be 2 times 2. And the prime factorization for 36 is 2 times 2 times 3 times 3. And once again, to find the least common multiple, we identify each factor the greatest number of times it appears. Well, I see 2 factors of 2 here and 2 factors of 2 here. So it doesn't matter which, pair we use. We choose one of those, right? Because we have this, it appears the same number of times. I have 2 factors of 3 here. So my least common multiple, I write each of these as products. So that's going to be 2 times 2 times 3 times 3. 2 times 2 is 4, times 3 is 12. 3 times 12 would be 36. Well, that's not right. So let's try that again. 4 times 3 is 12. 12 times 3 is 36. We did something wrong here. What did I forget? My times 7, right? We make mistakes. Right? I have times 7. So I'd have to underline that, and that would have to be a part of my prime factorization. Right? We have to be careful. We have to circle each factor, the greatest number of circle each of our primes, but we have to write them in our prime factorization. So we have 2 appears twice as a factor, 3 appears twice as a factor, 7 appears once. And we need all of that in our prime factorization. So we find that least common multiple. 2 times 2 is 4, times 3 is 12. 12 times 3 is 36. 36 times 7, 36 times 7, 6 times 7 is 42, carry the 4. 4 times 7 times 3 is 21. 21 and 4 is 25. So 252 would be the least common multiple of 28 and 36. All right. Let's try one more. We have 24 and 90. All right, for 24, I'd have, let's see, 3 times 8. 3 is prime, 8 is not. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. They're both prime. So the prime factorization of 24 is going to be 2 times 2 times 2 times 3. Then we have 90. Do that up here. For 90, we have 9 times 10. Neither is prime. 9 is 3 times 3. They're both prime. 10 is 2 times 5. They're both prime. So the prime factorization is going to be 2 times 3 times 3 times 5. Now once again, we have to identify each factor, the greatest number of times it appears, to find the greatest common factor. So I see 1 factor of 2 here, but I see 3 factors of 2 here. So I have 3 powers of 2. 2 powers of 3 here, only 1 power of 3 here, so we use the 2 powers of 3, right? Because each factor, the greatest number of times it appears. 5 appears once. It's going to be a large number. So the least common multiple is equal to, it's going to be, let's see, 2 times 2 times 2. We have 3 powers of 2. We have 2 powers of 3 times 3 times 3 and 1 power of 5. Wow, let's multiply that out. 2 times 2 is 4. Times 3 is 12. 12 times 3 times 3 is 9. 9 times 12 is 108. 108 times 5 is going to be 540. 540 would be the least common multiple of 24 and 90. All right, so that's how we would use our prime factorization to find the least common multiple. All right, you could try a few more examples here. All right, or actually, we just did those, right? The on your own problems? Yes, we did. Correct. All right, we did 14 and 18, 24 and 36. Yes. Okay, so let's do, well, we didn't do 24 and 90, right? Yeah, we did. Okay, so let's skip ahead. And let's see, we're going to go to finding the least common multiple of 3 or more numbers. Okay, so if I want the least common multiple of 2, 5, and 8, I could list multiples, or I could use my prime factorization, right? Let's list our multiples for 2, 5, and 8 because they're small. 2, 5, and 8. For 2, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I don't think that's going to be enough. So we have 5, 10, 15, 20. All right. So you know what? I see that it's going to be, I'd have to list a lot of multiples of 2, so I'm not going to do that. So we're going to use the prime factorization, all right? So let's look at that. 2 is already prime. 5 is already prime. But for 8, we would use 2 times 4, right? And 4 is 2 times 2. So we'd have 2 times 2 times 2. If I use each factor the greatest number of times it appears, I would have 3 powers of 2, and I have my 1 power of 5 here. So my least common multiple would be 2 times 2 times 2 times 5. 2 times 2 is 4, times 2 is 8, 8 times 5 would be 40. So the least common multiple of 2, 5, and 8 would be 40, all right? Let's do the same for 6, 10, and 12. So we have 6. I'll change colors here. We have 6. I didn't want to use green. Boop. So let's go back to black. We have start with 6. Start my factor tree. 2 times 3 is 6. They're both prime. So we have 2 times 3 for the prime factorization of 6. For 10, I have 2 times 5. They're both prime. So the prime factorization for 10 would be 2 times 5. For 12, we have 3 times 4. 3 is prime. 4 is 2 times 2. They're both prime. So we have 2 times 3 times 3. We want to identify each factor, the greatest number of times it appears. I have 2 to the first power of here, 1 power of 2 here, 1 power of 2 here. So I can use any of those 2's. Okay, so we identify 1 power of 2. I have 2 powers of 3 here. I have 1 power of 5 here. So the least common multiple is going to be the product of 2 times 3 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. 30 times 3 would be, that can't be right because 12 is not a multiple. So either I multiplied wrong or did something wrong. Let me go back and slow down. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90. But 90 is not a multiple of 12. Right? So something is wrong. And let's see what we did incorrectly here. 6 is 2 times 3. They're both prime. 10 is 2 times 5. Right? That's correct. 12 is 3 times 4. 3 is prime. I see my mistake. Where is it? Right, another mistake. Here, I did the prime factorization incorrectly. I have 2 factors of 2 and only 1 factor of 3. Right? So I'm a little careless. Let's undo that. So let's recopy that. 2 times 2 times 3. And if I identify each factor, the greatest number of times it appears, 2 powers of 2 here, 1 power of 3, 1 power of 5. So let's try that. We have 2 times 2 times 3 times 5. 2 times 2 is 4, times 3 is 12. 5 times 12 is 60. And 60 is correct because 60 is a multiple of 6, 60 is a multiple of 10, 60 is a multiple of 12. All right? So we have to be careful. All right, made a mistake there, but I found my mistake, and that's going to happen. We continue. Okay, we just did, let's scoot down to the use of the Venn diagram. Okay, the Venn diagram is actually a helpful tool that allows us to find both the least common multiple and the greatest common factor. All right, so I'm going to give myself a little bit more space here, and I hope that works. Okay, first I identify, not inside the circle, outside the circle. First, I identify 30 for one circle and 36. And just to explain how Venn diagram works, the section of the Venn diagram where they intersect, those are going to be factors, prime factors that are common to both numbers. This section here will be prime factors that are unique to 30. This section here will be prime factors that are unique to 36. In order to find those prime factors, we start with our factor trees. So I'm going to make a factor tree of 30 for 30. That's going to be 5 times 6. 5 is prime. 6 is 2 times 3. They're both prime. Right? Write my prime factorization as 2 times 3 times 5. And then for 36, factors of 36 are 4 and 9. Neither one of them are prime. 4 is 2 times 2. They're both prime. 9 is 3 times 3. They're both prime. I write the prime factorization as 2 times 2 times 3 times 3. Now, here's how we use the Venn diagram. It's an organizational tool. I look for the factors first that are common to both. So I have 2 times 3 here, right? And I have a factor of 2 and a factor of 3 here. 5 is not common to both. 3 is not common to both. So I write the factors that are common to both here, right? Because they're common to both. So 2 times 3 is going to go inside the intersection. That is my greatest common factor. Greatest common factor is the product of those two numbers. So 2 times 3 is 6. Now I take my other factors that I did not underline. Here I have a 5. 5 is unique to 30. And here I have a 2 and a 3 that I did not underline. Right? And that is unique to 36. Right? 2 and 3 are unique to 36. This 2 and this 3. The least common multiple is the product of all of those numbers. So I multiply 5. Right? Let's underline them all. Right? All of that is my least common multiple. So I have 5 times 2 is 10, times 3 is 30. 30 times 2 is 60. 60 times 3 would be 180, would be the least common multiple of 30 and 36. All right? So to explain that again, inside here, right, are the factors that are common to both. 2 times 3, 2 times 3, common to both. Factors that are unique, 5 here, the 2 here, and the 3 that are left over, right? It is the product of all of those factors that's going to give me the least common multiple. Let's try another one. 22 and 55. Here's going to be a circle for 22. Here's our circle for 55. I start with my factor trees. 22 is 2 times 11. They're both prime. So 2 times 11 is the prime factorization for 22. I have 55. That's 5 times 11. They're both prime. So 5 times 11 is the prime factorization for 55. What are the factors that are common? Right? Just 11. So 11 goes in here, right? And that is my greatest common factor, right? Is 11. The factors that are unique, I have a 2 that's not underlined, that's unique to 22. I have a 5 that's not underlined, that's unique to 55. My least common multiple is the product of those. So 2 times 11 is 22. What's 22 times 5? 22 times 5, I believe, is 110. Right? So the least common multiple is 110, which is the product of 2 times 11 times 5. Right? That's my least common multiple. All right? Let me circle that. Right? Put a box around here. That times that times that. That's my least common multiple. All right? Try one more. We're going to have 16 and 40. So I'll put my 16 up here, my 40 here. Factor tree for 16. Factor tree for 16 is going to be what? 4 times 4. Neither is prime. So 2 times 2 here. 2 times 2 here. So I have 2 times 2 times 2 times 2. I should have mentioned it's probably not good to use exponents when we write our prime factorizations because it's easier to identify the factors if we're not using exponents. Right, so we have 4 times 10, neither is prime. 4 is 2 times 2, they're both prime. 10 is 2 times 5, they're both prime. So we have 2 times 2 times 2 times 5 for the prime factorization of 40. What are the factors that are common to both? 3 powers of 2, 3 powers of 2. So 2 times 2 times 2 is going to be the greatest common factor. 2 times 2 is 4, times 2 is 8 is your greatest common factor. The factors that are unique to 16 would just be the 2. The factors not on the line for 40 would be 5. So the least common multiple is the product of all these, right? So it's 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 5 would be 80, right? 80 is the least common multiple, right? That's going to be 80. All right, so that's the lesson for today. We had a couple strategies that we used. We listed multiples to find the least common multiple. We used prime factorization to find the least common multiple. And then we used the Venn diagrams to identify both the greatest common factor and the least common multiples of numbers. All right, I hope that's been helpful.